for us?
Yes.
Okay.
All right. So we're moving on to the next session, and it is my pleasure to introduce Dr. Peter Beeling and Ms. Sarah Stanford. Dr. Beeling serves as a CERC Research Council member, providing guidance in the Trusted Systems Research area. Dr. Beeling is a professor in the Hume Center for National Security and Technology within the Grado Department of Industrial and Systems Engineering at Virginia Tech. Dr. Beeling received his PhD in operations research from the University of California at Berkeley and has held positions at the Center for Naval Analyses and the IBM Almaden Research Center, as well as most recently at the University of Virginia. Sorry if I got any of the pronunciations wrong. The sponsor for this research is Ms. Sarah Standard. Ms. Standard is a Cybersecurity and Interoperability Executive Director for Developmental Test, Evaluation, and Assessments at OUS DT&E. Ms. Sarah Standard is a U.S. Naval Academy graduate and a retired Navy captain. Commissioned as a supply officer, she served 5 years of active duty before transitioning to the reserves. After earning her MA in Applied Mathematics from the University of Maryland, College Park, with applications in numerical analysis, operations research, and databases, she transitioned to the information professional community in 2004. She served for 9 years in the Navy Information Dominance Corps and 16 years in the Navy Supply Corps. Over to you.
Thank you. Okay. Good afternoon. Thanks for sitting in here. I appreciate it. So I am not the executive director. I'm the technical director under the executive director at Developmental Test Evaluation and Assessments. Okay, so I guess I have control. Are we also live and they can see it and hear me? Okay, so we have several topics to go through today. Peter and I do. I will start us off and go through the motivation and how we're moving towards a solution, and then Peter will take over from there. Okay, so we have a wonderful research team, of which all of them almost are present. Barry has since retired. Cody's moved on. Yes, this is from 2 years ago when we did our work together. So the work was focused on developing, being able to do developmental tests to demonstrate cyber attack resilience. And so there's some follow-on work here that's related. That first one is the one that I particularly funded that we're talking about right now. That's me. Boring. Okay, so all right. So the motivation behind this work for me has been that in my role at the Developmental Test Evaluation and Assessments, we have about 110 programs under developmental test oversight. I started there about 6 years ago. And the very frustrating fact is that our programs are not testing for cyberspace threats. And they don't know how to. They resist it. We don't have money for that. They don't have requirements. So they tend to focus very much on risk management framework and getting their authorization to operate, which we happily say is necessary but not sufficient. And so I'm sorry to say I am a card-carrying RMF hater, at least the way it's implemented today. So just know that that's where I'm coming from. So they don't consider, when they're doing risk management framework, they don't always consider that cyberspace threat to mission and what those threats really can do. So we need them to involve test organizations early, and they don't do that. They don't, because test organizations cost money. Government test organizations cost money. They don't bring those test organizations in early enough to help them in their engineering designs to better, develop a resilient system by using that knowledge that these testers have, because they are people who like to break things and do just because. So that kind of person in your engineering design phase is a critical component, unless you yourself think like a hacker. So it's important to bring them early, and our programs don't do that. Our programs don't require our contractors to do cyber test and evaluation. Yikes, right? We're just getting a system fully finished, too late to fix anything affordably. And we find stuff in developmental, if we do developmental tests by the government, and we find stuff in operational tests pretty consistently. So that's a problem. And then finally, our acquisition programs don't resource and perform enough of the government cyber test. They can't do enough testing. is the problem. So we want them to be able to do the right kind of testing, and that's where I've focused my efforts. So what ends up happening is we get this snapshot testing. Here's moment in time. It's not comprehensive. We have no idea if we've tested all the threat capabilities against all of the critical functionality of that system. And we find that our systems are not survivable, not operationally resilient when we do operational tests. So that's a problem that I wanted to try to move the needle, change. We'll see. So some quick definitions for you. So with respect to what is resilience, there are many definitions. I've chosen to list here the definition from our Office of Secretary of Defense for System Security, well, Research and Engineering, but for system security. So Ms. Melinda Reed is the director there. And this is a definition that she has proposed for resilience and a definition she has proposed for adversity. I think those are both very important definitions as we look at the work that we're doing. And then the DoD CIO defined operational resilience in our instruction that's listed there. I really like the operational resilience definition because of its focus on during operations. So those are important to me. So the question really comes down to, what are we supposed to measure? If you look at these definitions, we have to measure that ability to resist an attack, ability to absorb an attack, to recover from or adapt to an attack. That's what we should be measuring, but we need requirements to do that. So our testing must intentionally try to introduce the adversity into that system to see if it's resilient or not to that adversity. We don't do that today. Okay, so we also don't always consider the defender in our requirement writing, in our testing, our early testing. So the defender is a very important aspect, whoever that defender is going to be it the operator themselves or some other maintainer who has to update the system, all of those aspects. So as we look to move towards a solution, we are trying to focus on how do we achieve resilience by using the same system engineering processes really, but system security focus when we consider safety, reliability, and survivability without cyber. So we do those things, we do them well. They're very physics oriented, but that doesn't mean we can't tie cyber resilience in the same way to those same capability, approach it in the same way. So it's very important that we do that designing in. We think about how does our system need to be resilient when it's in the warfighting environment. And that means even if something changes in the threat environment, our system will still be resilient. If you are familiar with the honey badger meme from the past, we want our systems to be honey badger systems. They don't care what changes. So I'm promoting measurable cyber requirements that go along with the performance, the safety, and all the other abilities. So we want to measure the cyber effects when we're trying to measure that performance, that reliability, that safety, those other aspects. We have common mitigate and recover capabilities. We want to use those and not think about what caused the problem, but we still want to be able to mitigate and recover where we can. That's a big challenge with our weapon systems today. So if you're going to measure something, you need requirements. DoD does not do this part well for operational resilience. So our typical cyber requirements are those security controls from the risk management framework. They're defined upfront a lot of times without really understanding, again, mission and threat. So what we promote is to use the Joint Staff's cyber survivability endorsement to the system survivability key performance parameter. It's a mouthful, CSE. They've developed a CSE guide to help requirement writers write requirements, at least at the high level. So there are 10 cyber survivability attributes that can be tailored to the system. They are focused on, they are defined based on this mission type, the expected level of threat, the dependency level, and the impact if there is a loss. Now, again, those are very high level, but if you derive those down into the system, you can consider the impact of loss of each individual component instead of just the system, and you can focus on those critical components. So there's 5 cyber survivability risk category levels, 1, 2, 3, 4, 5, with 5 being the highest. I would argue that there is no such thing as a DoD system with a CSRC of 1 or 2. I argue with Joint Staff a lot on that one. All right. So here they are. Here's those 10 high-level cyber survivability attributes. Now, what typically happens is these are assigned to a system based on that score, that 1 through 5 category. And at the bottom, it gives you sort of a breakdown of how many CSAs are recommended by the Joint Staff. The Army has taken these and they're pretty much looking across all of them for all of their systems. So it'll be nice to see what happens there. And then within each of those CSAs, there could be 2, 4, 5 different, who knows, different, very specific, again, high level requirements for the system. And you notice I have resilience starts here for the mitigate and recover and adapt pillars. So those pillars, to me, are what we don't do well. That's where we don't write our requirements well. I would argue on the CSAs 1 through 6, that RMF kind of helps us with that. And I'm again, a card carrying hater of it, but it's not bad. It's just it isn't getting us to the mitigate, recover, and adapt at the type of resilience mindset with all the different adversity our systems can face. So here's a quick look at how the Joint Staff has written up CSA 7 and CSA 8. Don't expect you to read and study all these, but you can see that there's 4 different ones under 7, 2 different ones under 8. So this is how you get very specific. If you specifically notice the 4th one on CSA 7, there's a specified by sponsor. So that particular, whoever is writing that requirement for that particular capability, they need to specify the seconds or minutes or whatever it is for that particular requirement. Okay, again, so that's a system level requirement. It's not at the component level. And here's number 9, a couple of examples for number 9 and number 10 with a couple of examples for number 10. So it's good stuff, really good stuff, but now we need to take it into systems engineering. So because we need to measure things, we need to do engineering. And this is the part where we stop. Where we might have the CSAs, but nobody comes and does this engineering piece, which is a problem. So we know that the cyber survivability attributes are very high level requirements. So what we need is our engineers to write that up into a performance specification for that system based on the ConOps, the actual operational ConOps for that system. Write it up in a way that they can turn it over to the contractor. The contractor can then take that, flow it down, and decompose it into the lower levels of the system, all the way down to whatever level they need to go down to, and define specific technical performance measures at those lower levels. So what do the contractor need to demonstrate? Because the key KPP is a KPP. And when we give KPPs to our contractors, we expect them to test and demonstrate they're on track to meet that KPP and to tell us that at different design, technical engineering reviews. We don't do that with the CSAs. So that's another thing we want to fix. So if one of the ways we've found that's helpful to help understand if we can start it early enough, the cyber requirements for a system is to do mission-based cyber risk assessments. MBCRAs. So that's at the bottom here, right? So that's a really important technique that helps to shape the design of the system and helps to inform where we need to test and what we don't need to test. Because in cyber, we can't possibly exhaustively test. It's impossible. It's an infinite space. So, we know I'm probably preaching to the choir, but requirements need to be on the left, what they are. Technical performance measures should be what are defined on the right. They have to enable us to assess the implementation that as it's being built, not waiting till the very end when the system's delivered to the government. And so if we had these requirements, then we probably do a better job of cyber testing. Not that we don't do a good job of cyber testing, but we just come and do what we always do. It's not necessarily measuring anything. It's just, oh, I got into your system. I now have, admin privileges on your system. It's like, well, what are you really measuring? Why does that really matter? How do you communicate that to the warfighter? How do you communicate that to the program manager or the decision maker who's deciding whether or not that system's ready? So mission-based cyber risk assessments, it's defined here for you. They should be conducted early, again, to inform that system engineering. I have a great example of a company that I listened to at the National Defense Industrial Association at the beginning of November. Lockheed Martin presented a guide that they have developed called the Mission Impact Analysis, I think it is. And they are using, it's a mission-based cyber risk assessment of the mission, what's called a mission separable type, because we've done some studies on these things. And they are using it to derive the system requirements. It's like amazing that they're doing that. So if you want more information on that, let me know. But we expect a mission-based cyber risk assessment to help understand the attackable surface, understand what vulnerabilities, potential vulnerabilities, or some people call them susceptibilities, are in the system, provide us with actual ways to address those problems, and generate attack scenarios so that we can do testing when we do get to the testing. But this is not measurable stuff yet still, right? So we still need those measurable requirements. Here's where MBCRAs fit in. If you're familiar with the systems engineering process model, you've got that requirements analysis, you generate the P-spec using those cyber survivability attributes. Once you get down into design synthesis, before you even start building, you can conduct a mission-based cyber risk assessment there as part of your test and evaluation efforts, or as part of your engineering efforts would be even better. And then those feed back up into that requirements analysis and help you recursively and iteratively improve the system and its resilience. I think it's now time for Peter to take over.
Unless you want to keep going.
No, sir. Thank you.
Thanks a lot, Sarah. It's good to see everyone this afternoon. So let me start with the idea that if we, Sarah mentioned the importance of engineering, right? If we want to get to requirements for cyber resilience that can be tested, we're going to have to, whoops, okay. It was, okay, attract you, advanced technology, very good. Yeah, we have to think about engineering. And when you're talking about something like resilience, recall the definition that it's really conditioning on the system being under attack in a situation of adversity, and has to do with the question of how the system responds, right? What is its behavior to restore functionality, to kind of develop that that honey badger, I like honey badger videos, by the way, that honey badger kind of characteristic of being able to get itself out of any kind of situation and back to, back to some kind of functionality. So, the question is, in what ways can a system kind of develop those characteristics? And of course, the most clear pathway is to say that we're going to engineer in specific mechanisms that attempt to provide that kind of behavior and capability. And so I'd like to speak about kind of everything that we did on this project in the context of engineered resilience mechanisms. So we have the notion that there is some kind of function. I'll give an example here of one particular kind of mechanism, a sentinel-based mechanism that is focused on the idea of detecting an attack using something that we call a sentinel. And I'll give an example of that in just a second. And then potentially having detected that something's gone wrong with the system, that the critical functionality has been lost, potentially due to a cyber attack or potentially due to other causes, then engages in some kind of action that is the kind of resilience response that restores function, or that provides the fight through level of function until other mechanisms still can kick in and do the restoration. An example that I'll speak about, we kind of have a tag team. I'll just pause for a moment and just say that we have 2 talks in a row. You may have noticed that in the program, and the reason is that we're talking about work that we've already done that includes these kinds of notions, and I'm going to go into them though actually in more detail in the next talk, and there's a reason for that I'll explain at the end. So yeah, one example that I could give though very quickly of a resilience mechanism is an example that we worked with regard to UAVs. And so with the UAV that's pictured here, we were asked the question, could we deal with resilience for that vehicle? And what we ended up doing is first engaging in a process. And as we'll see as these talks unfold, that process has its roots in the safety community, but a process to identify what is it that you care about the most in terms of in terms of loss of system function or the preservation of mission capability. You know, the two sides of the coin. And in our case, we determined that what we were most interested in was the navigation system. So we wanted to preserve the navigation functionality for this vehicle. So it didn't end up going and flying to some other country, you know, or someplace it shouldn't go. So one way to approach that kind of topic would have been to work on the GPS unit, try and harden it. That would be a kind of conventional approach. A resilience approach that we adopted was to note that to our great joy and everlasting luck, there are two GPS units on this UAV, one for nav and one for the camera pack. And so that brings forth a very simple idea of a mechanism, a Sentinel, that could take the GPS units and using a very simple computing device, just compare their outputs and determine, you know, whether they were sufficiently close that you could have kind of confidence that they were in agreement. And having confidence that they're in agreement, you might then draw the conclusion that they haven't been hacked, because in our case, it turned out these two GPS units came from different manufacturers. So at least we could implement something that would increase the difficulty of an adversary taking over this aircraft. So that's one kind of mechanism, and I don't want to dwell on it too much, but you know, the notion is detect the attack and then do something about it, right? That's the resilience response. And in our case, for this example, that was switching modes of navigation, switching to inertial navigation. When you think about doing something like that, then you raise the question of, okay, well, now you're still navigating, but your performance is degraded. How much is it degraded? Does the system tell you anything about it? Does the system pass off that information to the operator? What's the operator think about that kind of choice? Are they part of the decision or not part of the decision? Are they well informed about it? Are they trained? All these kinds of issues start to spool out when you start to think about things in, as Sarah said, the framing that we have, which is operational in nature. We want to see how think about how these mechanisms might work as the system is undergoing adversity. And so that's the heart of what we worked on in WRT-1022, something that we call the Framework for Operational Resilience in Engineering and System Test, or FORST. And the notion is that, yeah, you know, if we're going to think about what resilience is to the point where we can begin to write down testable requirements that people can develop, contractors can develop to and test to, and the government can test to, then we really want to fold in the confluence of system functions, tasks, missions. We want to think about how a mechanism like the Sentinel and the resilient responses would unfold in terms of technology, the humans and who are the operators and mission commanders and others, the decisions that they're making and so on. So the FORST framework is pretty tough. Don't try and read this one. Okay, I see people leaning forward. It's like, no, and it's not going to work. This is slightly better, and I'll just walk through it a little bit, and I can go in a little bit more detail next in the next talk. But the basic notion is that, of course, every system is going to be different, right? But we could think about common elements that have to do with operational resilience, and that's the idea of the FORST frame, to try and provide a way of looking at resilience so that you're writing requirements that are at least covering some of the ground that has to do with these resilience mechanisms working the way that you hope that it would work in the context of an actual system. And that means considering all kinds of strange things that you might not have had in mind if you're just thinking about the engineering aspects of things. So you need to sense an attack, right? You need to try and isolate it and figure out which subsystems are affected, and what's the kind of blast radius of the attack, or the extent of the contagion. What can you trust? What can you not trust? You need to think about what are the resilience modes. Well, I've got inertial navigation. Do I have other options? Can I just do a forced landing or something like that? That might be an option to put on the technical terms, in terms of data forecasts, parameters that govern the anticipated performance of that of those resilience mechanisms. My internet connection's unstable, or what can it measure as those things are unfolding. What kind of data does it end up providing to the operator, and what can we expect about the operator's ability to consume that information and have confidence in deciding, yeah, I'm going to keep flying this thing in spite of what has happened, and so on. What could we do to prepare operators? Are there any requirements that we want to put on the system at large, or things that surround it that would have to do with operational perspective? What kind of information needs to be provided to the commander about the overall health, and how do they fold that into larger situational assessments? And then all the way to the life cycle and kind of post-event reflection and adaptation. So those are all the elements, and I think I'm not going to dwell on. I'll go into some of these in a little bit more detail, maybe in the next talk if you're able to stay. But I'll just say that we've thought about each of those different trees, we call them, right? And if we have a forest, we have trees, testable resilience efficacy elements. And for each of them, one can think about the framing that I just described, but also a set of measures and metrics that start to come to mind. A lot of them have to do with time, counts, things like that, but others can be based off of operator assessment. In the end, you can go through and translate those kinds of that general kind of thinking into a set of requirements. And how you do that, you're going to want to see the next talk for that, because that's going to be a little bit revealing of some of the things that we do in model-based systems engineering to support this idea. But just kind of jumping to the end, I'll say that we drive down to a set of requirements, and they're pretty hard to see here, and these are only meant to be examples. But there's there's an important, I think there's something to be said that's very pro for these, which is they may be the first ones that exist for this kind of set of questions, but there's also a big disclaimer here. It's in red. Can you see the disclaimer in red? So the disclaimer is that really these requirements and everything that I've described have to do with ensuring that we have some kind of confidence that there are engineering mechanisms are going to work in the way that we intended them to work. That doesn't necessarily mean that our system is resilient in all the ways that we want it to be. It's just with reference to the particular mechanisms that we've engineered in and how they might function. So the caveat here is that the requirements don't measure resilience, but they measure components or parts of what we'd want to have in order to form an idea of, yeah, we're feeling good about the resilience of this system, but we might not be able to say the resilience of this system is 5.7. That has not been reached yet. So we've done all this on a case study called Silverfish, and I'll give reference to it. I think I want to leave some time for questions. How much time do we have? 10 minutes? Okay, I'll just mention that we've done a case study on a system called Silverfish, and Silverfish is a derivative but hypothetical system. It's derivative from an actual Army system, but not in itself real. It is basically a modern landmine system where you deny ground to the enemy by placing obstacles, which are really munitions that sit on top of the ground in a very secure way, so they don't explode on their own, but they can be set off by an operator. So for Silverfish, we've developed an approach to kind of implementing the forest ideas that makes use of something that we call mission-aware cybersecurity that folds together MBSE, STPA, which is something that comes from the safety community, and resilience concepts like the Sentinel. And I'd be happy to talk about that a little bit more at the next talk. But let me just close by saying that what we focused on in WRT-1022 was the forest, the common forest methodology, the combination with mission aware and building out on the Silverfish. And again, I'm going to show a little bit more details in the next talk. But what we're actually up to in the next talk is really a project called WRT-1022 that's just starting. And the exciting thing about this project is that it's a pilot of all of these ideas, not on a hypothetical system like Silverfish, but on a real weapon system that is at scale. It's a major program. And excitingly, it's a major program that exists in the digital world. So they've been following the digital transformation and some of the things that Ms. Baldwin talked about, during the keynote and other things. So we have a lot to work with in terms of, a set of models and a digital kind of framework that the program itself has been following. So we're going to talk a little bit about, what it'll mean as we go forward. A little bit more detail in the next talk about what we've done, and a little bit more about going forward. But let me stop there and we'll jointly take questions. Okay.
I stunned you before we put you to sleep. Any questions? Well, of course, good number of these people are your team.
Yeah.
Good. Do you have one? Yes, sir.
Actually, I had a comment on standard sketch out from the Crow's office. You had a nice little bullet, really small. I think you mentioned it, but it said needs sustainment cyber T&E.
Oh, yes, I didn't. I don't
It's a
think I
very
mentioned
important bullet.
It is.
That we live in, because about 90% of our programs are in sustainment and legacy.
Right
Right. And a large majority of those are not ACAT 1, ACAT
That's
2
right.
programs with the type of money that can do all the things that are on the flow chart.
Right.
Right. And so trying to reverse engineer some of those programs to turn them into digital models. So maybe we can get some, efficacies from that, or some efficiencies from testing in the model. But really struggling with finding money. So when we've got programs, I do data analytics for the systems which are affecting our broad swath of weapon systems in the Air Force. And I have a good insight onto which systems are critical to getting an airplane off the ground. And it's not the airplane, right? But those programs are in life support.
Yes.
They don't have the money to go do T&E. They certainly don't have the money to change anything, even if they found something wrong. So
Right.
how can we fix that
Yeah.
problem?
Well, so that means the Air Force needs to say that these systems need to come back through for an engineering update, right? We have to make that decision, because otherwise it will never happen. They will never get funding. And then when we do that engineering change, we need to define a lifetime of testing for that system, for those critical systems, because we cannot afford for them to be hacked, to be down because they were hacked, right? So we would have to, RMF isn't terrible, completely terrible. RMF has requirements that define testing, right? CA8 for you have both penetration testing and red team testing. If you assign those to the system and say those have to be done at this periodicity every year, for example, you have to do this testing at a minimum, then the program manager will have to POM for that sustainment budget to be able to do that testing on an ongoing basis. And they would have to plan to mitigate those things too. So if we put the requirements up front that this system's going to have to be tested at the sustainment stage endlessly till disposal, well, then that drives POM. And I think that's what we don't do personally. So maybe, I mean, we can't fix programs that aren't ever going to be, the threat has changed since those things were fielded. And that's just, if our missile systems had a new threat to them and they could no longer do their job, we certainly would put them through an engineering change. But far be it from us to think about the cyber threat the same way. We need to do that. And I think Crows is positioned probably to make that argument the best for the Air Force. Of course you can. Please, Tom.
So just to add a comment, and I think what you'll see in the next presentation in this discipline system engineering process, you can at least go through the process up front and do this STPA SEC-based loss analysis. You can understand what are the things I can least afford to lose in this system. You can drive that down into MBSE-based meta model that conceptualizes what you might put into the system in the future and sets up those priorities for you in the future. Even if you don't have money to implement it, I think just walking through the
having the
process is
awareness,
gonna
absolutely,
cause a
I would
whole
agree.
lot of value added in what you do.
If you are going to model those systems, truly model them, reverse engineer so that you have a model so you can put them in your overall federated model for your mission space, then I think that's a great opportunity to do mission-based cyber risk assessments combined with STPA SEC to say, what if, and what do we need to care about? And that might drive the need to do the engineering changes that might be needed or might not. You might find out there aren't any. Who knows? Thanks for the question.
Yeah, Sarah, maybe you could speak to that this ends up, the whole point of what Tom is suggesting in combination with the mission-based cyber risk assessments would be to be revealing of some kind of trade space.
Yes, that's exactly the point.
That's right. So you're going to get, some kind of prioritized list of, I care about this the most, and on down. And
You're probably familiar.
What you might have to do to fix each one, and that ends up defining some.
MRAP-C
Yeah.
should be doing that.
So the problem, I support agile, I support current session, ground support equipment models. RMF has bucketized everything, right? So I've got an aircraft AO that's supposed to just look at it, and then maybe I just look at it once. They're all MD sides. So when we do mission threads as part of MFC, we look at an F-15 and its mission threads, and it stops at the boundary of this other stuff that's outside.
Well, then you can do system of system mission threads. The Air Force Crows could do that.
Right. And so we're getting to those.
We've done those with Missile Defense Agency where we've looked, but they're an agency who kind of manages all of those parts and pieces. So, but it's really important, I think, to do that. And I think, well, ANS is also doing some sort of, that kind of resilience at the mission level assessment kind of war game thing that they're doing. So maybe Crows should be more active when ANS performs those war games.
Yeah, and I think we could give you a tutorial just on Silverfish, because Silverfish is a system that involves a bunch of smart ground obstacles, an operator station, UAV, a human observation. All these things are integrated together, and it's in a simple system of systems. And so it's really informative about how you do this analysis in something that's larger than a single platform, right? And that's why we like Silverfish. It's a great training tool. And so we are actually trying to integrate that into DAU's training now.
Yeah,
And so-
scaling that up to a JADC2 would be far more interesting to me, because I think because we just, in a JADC2 environment, we don't know which system's going to be doing the whatever, right? It's good. There's too much
I think
dynamicism there, I
you're gonna
guess.
find a whole lot of, never want to connect this thing to a JADC2.
You probably would find that.
It's too high.
But yeah, these are all good discussions. I think these are important challenges that we all are trying to tackle and don't have the answers. This is one piece of the puzzle, I really think we don't do requirements well for resilience. And so I'm hoping that with this demonstration for next year, this year's work with the program we have, you know, it's like Pinocchio. It's a real program, a real boy, right? It's pretty exciting. I hope we learn something that we can share across the services as learning points.
And just as a teaser for the next talk, that when we do mention something about what that next program is going to be, there's the idea that we're going to take the kinds of stuff that we were talking about here for us, but also be informed by a bunch of other methodologies and groups.
We actually have Joe Una as an
Yeah.
advisor. Do you know Joe?
Joe's
Crows?
At a minimum, a convincer.
He works for Katie on the systems. Joe Una. Yes, you know Joe. So he's one of our advisors. He's one of our kibitzers. Yes.
Yeah, at a minimum, a convincer.
Yeah.
You know, and more than that, you know, sky's the
Right.
limit. And we're looking to, you know, we have these ideas. We've tried them out on the system. It's a nice system, Silverfish. It's not a real system. And we haven't, we want to go through the iteration at scale and in the context of other ideas as well.
Theory only gets you so far. In the resilience space, it's been theory upon theory upon theory upon theory upon theory. Right now, we want to really actually see practical implementation.
That's a teaser. We stay for the next one. That's some more good discussion.
Thank you. I think it's good. Oh, hello, hi. All right, thanks for the
Thank you.
teaser, and we hope to see everyone back in 15 minutes.